Now, in the previous section, we learned how to take a particular z-score and figure out the area to the left of that z-score. We also figured out that we can figure out the area to the right, the area between two z-scores, but this is essentially what we did. We got very good at going from a z-score to a percent, a left-sided percent. And in this section, we're just going to say, well, if we can go from a z-score to a percentage or to a probability or an area under the curve, those are all the same thing, right? We can probably go in the other direction. We can go from a particular area under the curve to a z-score. And this is incredibly important when we talk about being in like the 90th percentile for weight or something. It's a lot easier than looking up every single person and saying what their percentile is to just figure out what that is as a weight and then be able to report that out and say if you're above this, then you're outside that range. And again, I'm thinking about kids because when you're a kid, they always tell you your percentiles. So our first question, all we're going to do is we're just going to work on this part of it. We know eventually, and that's what we'll do in the next video, is we'll put another step and we'll actually go straight into, weights or heights or whatever the heck we might be looking at that's normally distributed. But for now, we're just going to make sure that we can find z-scores from percentages or from areas under the curve. So if we go with the last question, I'm really trying not to say the word so, and it still happens. And every time it happens, it drives me crazy. And then I start this video over. But I've started this video 4 times now. I'm not doing it again. Anyway, another filler word. We know a lot about our z-scores. We know they're normally distributed. We know that the mean of that normal distribution is at 0. And we know that each side of the curve is 50%. It's half the curve. So when we're talking about the lowest 10%, we know we want to shade what we think 10% of the curve is, and we want to shade it on the low end. So we would shade until you think you shaded about 50%. And this is totally arbitrary. But we know that this is 10%, and we want to figure out what the heck this z-score is. Right? We're moving the opposite direction as to what we did previously. Well, we have 2 ways we can do this. One is terrible. We could go to the table. So if we went to our table, our good friend, now we want to use the table in the opposite direction, right? Instead of having a z-score and going, oh, cool, this and this together, oh yeah, we have the answer. We have the 10%, and we want to know what the z-score is. So 10% is 0.1. Now we are on the very exciting number search of trying to figure out where the heck 0.1 is in this table. So we go through, we look, it does go in order, so at least we have some help there. The closest thing we have to 0.1 is 0.1003. Here we get a little bit further away. So all we do then is look the other direction to go out and figure out what our z-score was. So in this case, our z-score was a negative 1.28. So let me go back to our work here. All right, we know our z-score is a negative 1.28. Now, the nice thing about having this drawing as opposed to using, this is the probability notation for this that I don't like, by the way. A z-score is less than some z we don't know is equal to 0.1. This is the notation. This is, to me, does not help at all. The drawing tells us a lot more. We can see from the drawing that our z has to be less than 0, and we got out a negative z-score, so this totally makes sense, and we can feel good about it. Now, unlike last time where I made us do all of these questions using the table, I am not a huge fan of the table for this one, right? It is not a fun thing to do. Searching through the middle is not easy. And then there's always the issue of every once in a while you end up directly between 2 values, and what do you do? So the calculator, all of them, including the graphing calculator and the little 36X Pro, will do this. I'm going to turn my wizards on for the first one. So it looks like the 36X as well. So if you go over, to distributions, inverse norm. Inverse norm undoes what we did in normal CDF. Inverse norm is what we want. So inverse norm, if we click on that, it asks us for our area. And the big thing to know here is that the inverse norm only takes a left side area. So inverse norm takes the left percentage or area or probability, and then you can feed it the mean and the standard deviation. So in these cases with our normal, our standard normal, our mean is 0 and our standard deviation is 1. But this particular question, our first one, is set up perfect for this. We have a left side area. We just press 0.1, and it tells us that our answer is negative 1.28. And of course, it can give us more decimals because it has more accuracy than that table. So we could actually get a more accurate or better answer to this one. So if we move on to the other two questions, highest 30%. Now we're going to shade 30% of the curve, but the highest tells me that I want to shade this on the right-hand side, on the higher end. I'm going to shade until I think I've shaded about 30% of the curve. Again, this is arbitrary. The only piece that really matters to us is that we have not come past the 0, because that would take us past 50%. And we know that we're somewhere here. So our z-score is there, and this whole area we just shaded was 30%. So as we continue to move forward, this is where if we do inverse norm without thinking, I'll just go ahead and do it. If I did inverse norm and I just typed in 0.3, it tells me that my z-score is negative 0.5244, which does not make any sense considering I have a z that I put above 0, so it must be a positive z-score. Why? Hopefully you're sitting at home going, Kelly, you're being an idiot. Remember, you just told us it only takes left percentages, so you can't, if 30% is on the right, we know 70% is on the left, and that's what we should be doing in inverse norm. I should be doing z is equal to my inverse norm of 0.7. And remember, this is just like when we previously talked about this. If you don't have the stats wizards, if you have an older calculator or you've turned them off, when you go to your inverse norm button, you don't have that little helper menu, and you can just type in 0.7. You don't need to give it a mean and a standard deviation because it knows the mean and standard deviation are 0 and 1. So we can see now we get out a positive 5244, which is the correct answer for our z-score. Makes sense based on our drawing. Also, if we had done it the wrong direction, as long as we have the drawing, we go, oh, oops, I forgot I looked up the wrong side, and you just make this thing positive. So it's not a huge deal if you do the wrong side, as long as you have the drawing there and you're checking it to make sure that your answer makes sense. The last one here is middle 70%. So with middle 70%, still at 0, they're now telling us that the 70% is in the middle. So we're going to shade and go like this kind of, and we're trying to shade so that this is 70% of the curve. Now, if we remember our rules about the empirical rule, almost 68% of our data was between plus or minus 1. So 70%, these should be right around, these two different z-scores should be right around 1, because that was 68%. So we actually have two different things we're looking for here, a z-score 1 and a z-score 2. For z1, we're going to need to do an inverse norm, but we need to figure out what a left side probability is. So I'd like you to take a moment, pause, and see if you can figure out what I should be typing into inverse norm. All right, so in inverse norm, you don't want to type in 0.7 because that would be saying this, which is not what we have at all. Instead, we need to think about, okay, if 70% is in the middle of our curve, how much is left over for the two tails? 30%. And we have two tails and they're symmetric, so that means that we should have 15% in each of our tails. So we can look and see to the right or to the left of Z1, there's 15%. So that's how we're going to find Z1. So I'm going to do inverse norm. Should just use second enter. Oh, I didn't even do it. I'll do second, enter, bring back inverse norm. And I'm going to do this for 0.15. So our first normal here is negative 1.0364, which makes sense. It is right near 1 like we said it would be, and it's negative. Z2, you have two ways to get there. One, this particular distribution is symmetric, and we know that. So we know that the answer is just going to be positive 1.364 because they have to be the same distance away from 0. Or if you really wanted to think about your left side probability here, the probability of being to the left of this value, well, that is the 70% in the middle plus this 15% on the side for a total of 85%. So if we did inverse norm of 0.85, we'd get that positive. But we don't need to do that. We could just do one of them and then just remember it's going to be positive or negative. So that's how we can use the table if we had to, or more hopefully the calculator to find our inverse, or to find our z-scores for a given area under the curve.